Hello, it's Sabrina here and welcome back. So in the last video, I had an overview about Flutter state management and different way doing it and why we are managing state, and I also shared the screen how my company's app is managing the state, how our code is structured in in a way that's similar like Redux, but we are not using any package. So it's very possible. There's very possible to customize, and most code will use a package, and more convenient. So in this video, we continue with his course, and as you can see in the URL, right? And we are in module 3. We are going to learn Flutter app architecture. I have already watched some video. There isn't a lot of information. Honestly, you can just you can just read the article, which is public. And so he wrote a lot of video about a lot of article about state management and using the Riverpod. Then somehow, so he was saying like Riverpod is not very opinion, means it doesn't have strict rules on how do you structure the code. There isn't offer any guidance. So he offered some guidance, your code structure folder, where to put everything, which is very good. And he present with the presentation layer with widget, state, controller, and then you have application layer, which is services, domain layer, model, data layer, where you will connect with the APIs and other third-party services to fetch data, which will be then updated, go through each layer, and eventually show in the presentation layer. And just keep in mind, there are many different ways on doing this, and this is more like in a design principle rather than how to code. And different person may call differently. Some people may call domain layer as the main business logic model in the data layer, but the name is not that important. You can name anything you like. And while we are focusing on this course, we can focus on his name. The domain will mean the data domain, the data model class. Data layer will be different, which I'm also trying to learn how why he named this. This is a good one. So you see every different section will connect with application layer, which is the service class. We will see the code to have a better understanding, and there's a lot of more articles on comparison of popular. I read this one too. This one is good, but again, it's very general, a lot of theories. So I will include the article link, and you can read. And today we will continue to read, to listen his course, and change the code along the way, because I'm not focusing directly into the source code. So the current state is what we have left in last session from module 2 navigation, and there hasn't been update yet, but we will watch the video on the other screen, and in this screen you will see me coding, and I hope you also follow along and code with me. And you can grab this code in in the GitHub branch and check out the section 3, and then you will be able to follow along. So app architecture number 3. Okay.
Now that we have seen an overview of some of the most popular app architectures, we are ready to focus on the Riverpod app architecture that we have discussed, since this is what we will use for this course and this specific project. And the first thing that we can notice is that this architecture is based on 4 different layers called the data, domain, application, and presentation layer. And up until now, we've been focusing mainly on the presentation layer because this is where all our widgets belong. And at the moment, our project has very little logic and doesn't even talk to a remote data source at all because all the data is hard-coded. But of course, if we want to turn these into a real app, then we need to figure out how to deal with application state and communicate with a remote backend. And compared to the logic for showing the UI, these are very different concerns. In fact, the number 1 reason why we had these layers is to promote a good separation of concerns. And every time we need to write some new code, we should ask ourselves to which layer it should belong. And as we make progress, we'll get a deeper understanding of how all these different layers work and how they communicate with each other. And one thing that I'd like to make clear is that...
Sorry, I have a message. Okay.
Regardless of what specific architecture and design patterns you use in your apps, the most important thing is that you should define clear contracts and boundaries between the unique components that make up your application. Because without boundaries, it becomes too easy to write unmaintainable code that doesn't scale as your application grows in complexity. And there is an entire discipline known as domain-driven design, which was created to help us develop complex software projects. And as far as this course goes, we will borrow some ideas from domain-driven design as we explore our problem space and build our e-commerce app. And like I said before, if you head over to my website, you'll be able to find a number of articles that describe the architecture that we will use, covering all the different layers in detail. So I recommend that you spend some time reading these articles and keep them as reference because they will be a good complement to the content that we will cover in this course. Alright, so let's get back to VS Code and let's see if we can get a better feeling for how the current project structure is related to this architecture. Okay, so as we have already seen, all the pages in our e-commerce app are implemented inside this features folder. And right now, this only contains the widgets themselves, which belong to the presentation layer in our architecture. And at the moment, our project doesn't have any controller classes, which is something that we will introduce later on in order to handle user interaction and manage the state of our widgets. Likewise, we don't have any services in our app just yet, and this is also something that we will introduce later on. And as far as the domain goes, we do have some model classes that we have defined inside this folder. And as we have seen, for the time being, we are using some hard-coded values for these model classes so that we can show some dummy values in the UI. For example, in order to show the list of products, we use a global list variable which contains all these hard-coded values. But this is not how these things work in real apps. Instead, one of our goals is to read the products data from a backend, which is the concern of the data layer. And if this backend is a custom REST API, then it will return data in JSON format, and we need to convert that data into entities or model classes that we can use in the rest of the app. Not only that, but reading data from a backend is an asynchronous process because it takes time for our request to reach the server and for the response to come back. And if we use a backend such as Firebase that supports real-time updates, then we need a way for our app to rebuild whenever the data changes. Either way, this means that we need to read our data using a future or a stream-based API. Likewise, if we want to write some data to the backend, then we'll also need to use future-based APIs with async and await. And of course, since sending data to the network takes time and some errors may occur, we also need to deal with these errors across all these different layers, so that we can handle loading and error states in the UI. And all these requirements are not specific to this particular app, but very much apply to all apps that need to talk to the outside world. But once again, it should be clear that talking to a backend and dealing with data serialization should not be the concern of our widget classes. And as we will see, one big advantage of moving all this logic behind a repository is that we'll be able to test our app much more extensively. In fact, we'll even be able to write integration tests that can check entire user journeys in the app, and I prepared this video to show you an example of this. And the way this works is that this integration test is testing the entire app using the real presentation, application, and domain layers. But rather than talking to a real backend, it uses fake repositories that only simulate its behavior. And as we will see, this is fairly easy to accomplish because we can swap out the entire data layer as long as we define a clear boundary across layers. Alright, so hopefully this lesson has given you a good overview of our desired architecture. And one thing that I want to make clear is that this is a scalable architecture that makes it possible to add more and more features to our app without getting into trouble. So just like we can scale our app vertically by introducing each of these layers, we can also scale horizontally by creating multiple repositories, models, services, and widgets. And in fact, I want to give you a quick preview of all the different classes that we will have in the completed app. And as you can see, here we have the 4 different layers that we have defined. But we also have a number of different features that we can use to complete various tasks in the application. And for each feature, we can identify various classes that belong to these 4 layers. So we'll have plenty of time to learn about all these layers and the rules for communicating between them as we make progress. But the main takeaway of this lesson is that this is a scalable architecture that allows us to add new features in a consistent way by following certain rules about what code goes in which layers and some conventions about how our project should be structured. And as we will see, this will help us immensely to keep things in check as we tackle complex features in this project. So let's continue in the next lesson where we will talk about project structure.
Okay. I hope you can hear it clearly. The screen, by the way, isn't that much. It's very similar. Got some slides in his article, so you don't miss much.
In this lesson, I want to talk about the project structure and how it relates to our desired architecture. And when it comes to project structure, one decision that we should make early on is, should we use a feature first or a layer first approach? And this is a topic that I have covered in depth on this article on my website. So let me give you an overview of the difference between feature first and layer first, and then we can see how this applies to our project and the specific architecture that we are using. And the main idea with feature first is that we can organize our project by creating one folder for each feature. And inside it, we have one subfolder for each one of the 4 layers. On the other hand, with the layer first approach, we have the layers themselves as top-level folders, and we can add the features inside them as subfolders. And as far as our e-commerce app goes, this diagram shows us a high-level overview of all the features that we will implement in this project. So our choice really is about how we should nest our folders and decide if we should use top-level folders to represent features or layers. And this is not a big concern if you are just building small apps, but for medium and large-scale apps, then this decision is very important. And what I'd like to point out is that the layer-first approach has some drawbacks that become obvious as soon as our app starts to grow. In fact, the main problem with the layer-first approach is that when we are working on a specific feature, all the files that belong to that feature are scattered in different places. And this means that we have to jump to different parts of the project if we want to make changes. On the other hand, the feature-first approach is much more logical, because for any given feature, it keeps everything in one place. And since we will work on one feature at a time as we make progress, it makes sense to choose the feature-first approach for this project. And this is the folder structure that we are after. However, if we take a look at our project and try to figure out how it is structured, we can see that we do have this feature folder with various subfolders inside it. And we also have this models folder that stands on its own and doesn't really seem to have a close relationship with our features. And the reason we ended up with this structure is that when I first developed this app, I made a mistake. And that was to focus too much on the UI before figuring out a good project structure. And And the result is that these folders represent all the various screens that exist in our app. But this is a problem because features and screens are two different things. And using a feature-first approach is not about the UI that we see on screen. Instead, it's better to think of features as functional requirements that help the user complete a certain task. And now that we know about app architecture, we are better equipped to set things straight and choose a project structure that is truly feature-first. And to make things easier, I'm not going to guide you through an entire refactor of all the project folders. And instead, I prepared a new starter project that we will use as reference as we go forward. And this project works exactly in the same way as the one that we have been using up until now. And I haven't made any code changes in the files themselves. And the only thing that I've changed is the folder structure. So at this stage, please go ahead and open your terminal. And then you can discard any working changes that you may have by running git reset --hard head. And then you can run git checkout section.
So check out to section 3 starter. Let me see. Do I need to
3-starter to get the new starter project.
You can access all the branches in the GitHub
get.
too. You can
And once
just
this is
check out
done,
to
try
listen.
running the app to ensure that everything works correctly. And if you encounter any errors in building the app, please follow the steps below to resolve them. But again,
So that's interesting. Yes. Let's go to our terminal. Let me see. Gate status. I already commit, but gate checkout. Checkout section 03 starter STR. Okay, cool. So make sure you also check out the code in his GitHub is very well organized. So you know we are in module 3, is section 3, the starter. And let's see what's changed. So he mentioned at the beginning, we put the module folder as a separate folder. And he discussed about feature first versus layer first. So in my company, we use the layer first, and it indeed became a big problem as the app code grows. Because every time you add a new feature, it became a lot of work to go through. If you want to work on one feature, you have to go through all over the code to find what you need. So let's see. Yeah, so address, for example, you add domain, and this is model class in the address folder, and then you have a presentation with screen. So I like it. Let's see, product presentation. I guess the downside is sometimes if you have a code you want to share, you may, let's say, a common widget, then you want to reuse. I guess you can add a separate widget class in the folder that can be shared by each features. But again, there will be some. For example, if you add localization, you probably have one folder that contains all your text, right? That can be a good thing. Or let's see, I'm curious where he will add the service class. Okay, let's continue.
You should see is that the app starts and works as intended. And now that we have this project, let's take a look at the various folders and see how they are organized. So let's open lib and then source inside it. And as you can see, we still have a features folder over here.
No,
but we no longer have a models folder alongside it. And also the names of these folders have changed. And to get a better idea about what's changed, let's open the products folder, for example. And as you can see, inside you can find domain and presentation folders. And the domain contains the products.dart file, which defines our product model class. Whereas the presentation folder contains the product list, product screen, and home app bar folders that we need in order to show all the UI in the products list and the product page. And one thing that should be clear is that as far as we are concerned, any given feature can now include one or more UI pages, and these are always located inside the presentation folder. And the other thing that I want to point out is that at the moment, none of these features include the application and data layers, because we haven't started implementing any of the code that goes into these layers just yet. And we'll have plenty of time to see what goes in these layers. But for now, the main idea is that the purpose of the data layer is to hold all the code that we use to communicate to external data sources, such as a local or remote database. And we'll explore this layer in more detail in the next lesson. And as far as the application layer goes, its main purpose is to hold some business logic that can be shared by multiple pages or widgets in the presentation layer. And this logic lives inside service classes that can access more than one repository at once. Okay, so let's get back to our project structure. And once again, this project works when that you spend a bit of time going through the new project, and I promise that we will stick to this folder structure for the rest of the course. And I also recommend that you read this article, which explains the entire setup and the reasons behind it in more detail. And the big takeaway of this lesson is that going feature first gives us a scalable project structure that works great as our apps grow in complexity. And while every project is different and you should always figure out what is the best project structure based on your requirements, it's safe to say that for most medium-sized projects, this structure will work really well, and I advise you to try it out in your own projects. Okay, so let's continue on the next lesson.
So he said, for most medium-sized project, this works very well. I'm not sure, so for the large project, which one works better? Definitely not the layer first. Yeah, maybe there's something more different. Okay, now we are going to this one, number 6, implementing fake product repo as a singleton.
In this lesson, we are going to talk about the data layer so that we can start to understand what is the correct way of getting data from a backend and into our widgets. And before we start writing any code, I want to point out that on my site you can find this article that goes through the repository pattern in great detail. And you can use this as a reference as we make progress. And for now, I just want to give you a brief explanation about the data layer. And as you can see from our architecture diagram, the data layer contains repositories, data sources, and DTOs, which is an acronym for data transfer objects. And the whole purpose of the data layer is to connect our app to the outside world. And the outside world includes things like a remote backend, a REST API, a local storage system, or even native APIs that we can access via platform channels. And as far as our app is concerned, all these APIs can be considered data sources. However, the data that is returned by these data sources may not be in the format that we want. For example, if we talk to a REST API that gives us data in JSON format, it's not a good idea to use that JSON directly in the rest of the app, because JSON objects are not type safe and they are not immutable either. And as we will see, type safety and immutability help us write code that is safer and more robust. So the purpose of the data layer is to take the data from the help us write code that is safer and more robust. So the purpose of the data layer is to take the data from the data source and convert it to model classes that can be used by the rest of the app. And to do this, we can create some repositories whose job is to transform these data transfer objects to model classes and give us a clear interface for talking to the outside world, so that the rest of the app doesn't have to worry about data serialization and other implementation details. And one great benefit of using repositories is that they can be swapped out for testing purposes, and as we will see, this will help us immensely when we'll talk about integration tests later on. And now that we understand the purpose of the data layer, we can get back to our e-commerce app and start using it. And as you know, a lot of the data that you see in here is just made of hard-coded values and doesn't come from a backend. And whenever we deal with data that should come from an external data source, we should use the repository pattern to make it accessible to the rest of the app. And a good way to figure out which repositories we may want to create is to look at the model classes that we already have. For example, inside the products folder, we can open this domain folder, and since we have this product class, it would make sense to create a products repository that returns a list of products. Likewise, inside orders, we can find an order class, and we could create an orders repository class as well, and so on for all the other model classes. So all we have to do is to take the first step and decide which repository to create, based on the features that we already have. And I think a good place to start is to create the products repository, so that we can get a list of products. And as we know, right now our app reads all this data from a global list variable that contains all these hard-coded products. And that's because we don't have a backend that we can use to read this data just yet. In fact, it will be only in the next course that we will focus on backend integration with Firebase. And since we are not going to have a real backend for now, what can we do? Well, one option is to implement a fake repository that could use some local storage or even an in-memory store to store all the products. And the other option is to spin up a live server with an endpoint that returns JSON data. And then we could write a repository to request and parse this data and return a list of products. But for now, we're just going to keep things simple and implement a fake repository that will hold all the products data in memory. And we can try to model the API of this fake repository based on what the real repository will look like. And of course, we'll have to make some assumptions along the way, but as long as these assumptions are reasonable, we should be able to plug in the real Firebase backend later on without much effort. And as we will see, creating a local fake repository that doesn't run any networking code will also help us in writing automated tests later on. In summary, what I propose we do is to create a fake products repository that will give us access to the products list using some asynchronous APIs. And by doing so, we will introduce a clear boundary between the data layer and the layers above it. Okay, so let's continue on the next lesson.
Okay, so interesting. So it seems like we don't have backend for this app, and for next lesson we will connect with Firebase backend, which I also purchased the next lesson, and we after this, and we will go to the other lesson, and let's go to the next session. Okay, let's continue, and let's try to finish module 3. Okay, I'm just going to play the lesson for next module. I think we should go into number 7. It looks like there's no coding on this module, and he just go overview of the app architecture, and you can find many.
In this lesson, we're going to create a fake products repository that we will use to read the products list in our widgets rather than relying on this global variable. And to start off, we'll implement this repository with the singleton design pattern, though this will only be a temporary solution until we have a dependency injection system in place. Okay, so let's get started by opening the products folder. And since repositories live in the data layer, inside here we can create a new data folder. And then inside we can create a new file called fake products repository.dart. And in here we can a new file called fake.
Okay, so in the products, you create a new folder called data, and then why it's okay, anyway. inside of the data we create think
products repository .dart.
so fake products repository dot. Okay.
And in here we can create a class fake products repository, and then we need to add some methods that we will use to get the data that we need. And to keep things simple, for now let's just create a method that returns a list of type product called getProductsList. And of course we need to import product.dart.
Okay, let's stop. Get some fake products repository. The class. Whoa. They already get a lot of products. Let's see.
And inside the method body, we can just return 𝒂𝒑𝒆 which is our global list of products that we can import from here. And now that we have this in place, we could already try to use this repository. For example, we could go to the products grid file.
So, yeah, that's a code palette suggestion, which is not what we want. So, product get product list, which we already have the test product file, so we can just return key test products. Great. What's the code? Why? The file name isn't lowercase. Let's continue. I don't.
And as you can see, here we are reading the data from this global variable. So what we could do is to replace this code by creating a fake products repository instance, which we need to import. And then we can type .getProductsList to get the data that we need. And this expression is not a const value, then we need to declare this variable as final. And as it is, this code would already work. However, what we are doing here is to create a new instance of the fake products repository every time the build method is called. And this doesn't make a lot of sense, because this repository should only be created once and reused as needed. So how can we solve this? Well, this is a classic dependency injection problem that can be solved by using a service locator, such as the getIt package, or some other dependency injection system, which is something that comes with the Riverpod and provider packages. And if we don't want to introduce extra packages at this stage, we could implement something using inherited widget, which will give us access to the repository by using the build context. However, setting up an inherited widget requires a fair bit of boilerplate code, and we are going to change this approach later on anyway. So for now, what I propose we do is to turn this repository into a singleton. So let's get back to this class, and here we can add a singleton by typing static fake products repository instance equals to, and then we can call the fake products repository constructor. And then we can get back to our widget. And here, rather than creating a new instance, we can just type fake products repository dot instance like this. And once we get this instance, we can.
So this is in the product grid. Product presentation, product list, product grids. So in here where we are going to get the data. So we need to change this to product repository dot get product list, and it's not remote const. And what he means is every time when we call the build function, we get a new instance and then get this list, and that's not good. What we should do is go here and create an instance. So
repository constructor.
Static you see the suggested way is also different, so it's still a temporary solution. We don't have this private constructor, so it's only like this. At least you call the instance, which means every time it's one instance, and then get the product list. Yeah, it's I'm not sure why he's doing this way. As I said, this is temporary solution too. Okay.
And this code is still valid. And the way to prevent this is to get back to this class. And in here, we are going to add a private constructor. And the way to do that is to type fake products repository dot, and then we can use an underscore, and then open and close parentheses. And because we added a private constructor, then we need to make sure that we use it when we create our instance. So we can now save this file. And if we get back to our widget, we can see that this line is no longer valid. And the only way that we can access this repository is by using the instance. So let's remove this line, and then we can carry on. And now we have more work to do in our repository, because this is not the only page where we work with the products data. In fact, if we open the product screen, we can find that in the build method, we also have this line that takes the global list of products and filters it using the first where method. But this is not the kind of logic that should live in our widget. And instead, I think we should move it to our repository. So let's get back to our repository. And here we can implement a new method that returns a nullable product. And we can call this getProduct and give it a string ID as an argument. And then inside the method body, we can return 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 can use it to return true if the product ID matches the ID that was given as an argument. And just to be clear, the reason that this return type is nullable is that we may or may not get a match depending on the ID. And now that we have this new method, we can save this file and get back to our product screen widget.
Let me see first. Where? So why don't we response first or no? That's a 𝒂𝒓, I think. No? We don't have this method. Interesting. So first where maybe let me see. Because if it's no, it will return no already. Anyway, I'm not sure. The first element, if no element satisfies the result invokes, the function or else. Yeah, I remember we should have all else is not null, we return. Why there's no first of all or no? I'm always using this one. It says no defined. Or maybe that's our fix using no. Let's try. Oh, it's not a built-in. Yeah, I remembered. It's provided by collection package. Ah, that's why. So yeah, in my I usually imported the collection package. That's why it's safer to write first where or no. So then if you don't find the product in the list, it will return no. But if you don't have the collection package, I'm surprised he didn't mention this. I guess then you will see all else. You see all else for no. Is it necessary? No, I don't know. Yeah, it doesn't return those. You see, even if I remove the null, it's not showing any error, which is not good because if this line of code didn't find the product, then in the list it will show an error. Maybe, or oh, it's a function of no. I see. Let me see. All else no. It says wrong. I don't know why. I see. So in this product, it does not have the null value. That's why you cannot provide, you cannot return. No. Let me see what he said.
And here we can replace this entire expression with fake products repository, which we need to and now that we have this new
Yeah, he said, he gave a note saying first where or no will show and where we are here. And see, he gave a notes, right? It's very dangerous to use that line of code. And here's the notes. We have a private instance to prevent you keep creating the instance again and again. And he explained to here first where. Yeah, he said it should be all words is no. That's what I wrote. Yeah, okay. However, the type system will complete this error, yes. So here is a working solution. Okay. We have to use this one. See, I was correct. But if you use this package collection, it's better. Or I don't know, is it a library? Let me see. Or import collection. Oh, we can just use it's in already built in Dart. Or no. How do we? I don't know. What's going on? Okay. Yeah. You should see package. Okay, that's a battery. That's why we don't have the package. You know, collection is a very good package. So why don't we just add it? See, this is way better than this way, right? Try this. Okay, I will just great.
We can save this file and get back to our product screen widget. And here we can replace this entire expression with fake product repository, which we need to import. And then we can type .instance.getProduct, passing the product ID.
So then in the product screen, see, that's why I hope that's why my video can be slightly more useful for you. Okay, product screen. Now we need to change it here because we don't want to do the search inside the UI widget. So product repository dot instance dot get product and with the product ID. Perfect.
As an argument. And as you can see, we are now using the one and only instance of this repository because this is a singleton. So at this stage, we should be able to test our app and check if everything is working correctly. And as you can see, all the products show correctly, and we can go to the product screen page without problems. Because all we have really done is to move a little bit of logic from the widget widget classes into this fake products repository, and these two methods take care of returning the data that we want. Okay, so let's continue on the next lesson.
Okay. Almost done for this section. I think it's only this one.
In the last lesson, we have started implementing the fake products repository, and we have created these two synchronous methods to access the products data. However, let's keep in mind that the purpose of this repository is to model a real-world scenario where we read the data from the backend. And this means that the API that we use to read the data should be asynchronous. In other words, if we wanted to get this products list from a backend, such as a REST API, then our method should return a future. On the other hand, if our backend supports real-time updates, then we should use a stream instead, because real-time APIs are designed so that the server can push data to the client every time something changes, and streams are ideal for this because they can emit multiple items over time. So let's make some changes to this class and add some future and stream-based APIs that are more in line with what a real-world repository would look like. So over here we can add a method that returns a future of type list of type product, and we are going to call this fetch product list. And then inside the method body we can return a future.value with 𝒂𝒑𝒂𝒂𝒂𝒂𝒂 as an argument. So all we are doing here is to wrap this result with future.value, which resolves to a future that returns immediately. And since we are referencing this 𝒂𝒑𝒂𝒂𝒂𝒂 variable 3 times already, I think we should extract it in separate local variable that will become useful later on. So at the top here we can type final list of type product underscore product equal to 𝒂𝒑𝒂𝒂𝒂𝒂, and then we can use this variable inside all these methods instead.
Okay. So instant. Okay, after instant, what he means is we say final list of product. Yeah, it's I like the name fake products. Great. Oh, and they use a private constructor. Interesting. And then maybe we should name like this. Fake products. Or you can see test products. And here we have a future function. Future with a list of products. So 𝒂𝒑𝒑𝒂𝒂𝒂𝒂 suggests me this one, and I think it's pretty good. But what Andrea is saying is, let me first copy this. So I don't know why he's not using that, but what he wrote is not a sequence. Maybe he's going to change soon, but currently it's fetch. Oh. Sorry. Fetch product list, and the ID, and there's no await, and I guess return immediately a future value. I'm not sure why we are doing this way. Fake product. And let's listen. And he doesn't even have async because we are not waiting.
And just like we have created this method that returns a feature, we could also create a similar one that returns a stream. So in here we can add a new method that returns a stream of type list or type product, and we could call this 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 product as an argument. And this is nothing other than a stream that emits only one value. And as you can see here, this...
Let's see. So the name I did is slightly different. One is fetch product list. Another, let me see, a list of another called watch. I like 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 name, fetch product list stream. He named watch product list. That's fun. He basically say, hey, if it's a future, we use fetch. If it's a stream, we say watch.
And return a stream dot value with underscore product as an argument. And this is nothing other than a stream that emits only one value.
Yeah, only one.
And as you can see here, these two methods are very similar, with the only difference that one returns a future and the other one returns a stream. But the more fundamental difference between the two is that this method will be well suited if we are talking to a REST API where we make a request and we get just one response. While this method works better if we have a real-time API based on WebSockets or if we use Firebase. And for now, let's keep both of them because they are going to be handy later on. And while we are here, I also want to add an asynchronous version of this method which returns a product for a given ID. And I can do that by declaring a method that returns a stream of type product question mark. And I can call this watch product and pass a string ID as an argument. And then inside the body, I can return watch product list, which is this method over here. And then I can use the map operator to only return the products that match the given product ID. And this map will be executed every time this stream emits a new value, giving us a list of products that we can then filter with the same logic that we have used over here. And once again, for now, we only emit one value because we...
Okay, so we'll basically write another string method to get a product. Oh no, work. Oh great. Work products, take product ID, stream dot value, fake product. No, that's one of the way actually. But because we already have this, so what we can do is we can just call this work product list and then use the map function. Let me take this off. Dot map, we map through each product. Map products. Yeah, like this. And for this stream, let's give a note. Only emit one value.
Don't have a real backend, but this could change in the future. And our goal here is to define some future and stream-based APIs that we can use in the rest of the app. And now that we had these APIs, we could consider using them in our widget classes. So let's go back to our products grid. And here we could change this call and call fetch products list instead by using our new future-based API. And of course, here we get some errors because this return type is now a future. And we need to await for the result before we can use it. But of course, we are not allowed to use await here because we are inside a build method. And the build method is always synchronous because it needs to return a widget immediately. And if we want to get around this problem, we can use the future builder widget, which could take our future as an input and give us a builder that we can use to return a widget. Though I should point out that working with future builder is quite tedious because we have to write a lot of boilerplate code. And in fact, I've written an entire article explaining what is the problem with future builder and stream builder, and how the Riverpod package gives us some better APIs, such as a sync value that we can use to deal with this. And we will cover this in great detail as we make progress. So at this stage, we are not going to use a future builder because we will end up changing this code later on anyway. So let's undo these changes and continue using the getProductsList method for now, which is synchronous and works just fine in this build method. However, we are going to keep the new methods that we have added to the fake products repository, and we will see how to use them in the next section where we will add the Riverpod package. And before we continue, I want to make sure that we are using this fake products repository in all the widgets where we used to access this 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 global variable. And to do that, I can copy this variable name and do a project-wide search for it. And as we can see, this variable is still in use in these two files. So over here we are inside this shopping cart item widget, and what we want to do is to replace this old code, and instead we are going to type fake products repository, which we need to import, and then we can type .instance.getProduct.
So we are using this into another place, for example, shopping cart item.
And pass the item.productID as an argument.
Okay, so we want to update, we don't want to do list search. And this one also take oh, I think the yeah, if product is null, what do we do? Because this one will return null. Let's see what he said.
And as we can see, we now get an error down here because this method returns a nullable product value, but this widget down here expects a non-nullable product value. However, in this case, it is safe to use the assertion operator here when getting the product by ID, on the assumption that if a product was added to the shopping cart, then it can still be found by ID as long as products are never deleted from the database. And we will make this code more robust later on. Finally, let's open this order item list tile widget. And in here we also want to replace this code in the same way that we have just done in the shopping cart item. So let's copy this line from here, and then we can replace this code and paste it in here. And once again, we need to import the fake products repository. And as a result of all these changes, we can see that the only place where the 𝒂𝒑𝒑𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂𝒂 is defined is inside this repository. And this means that we have succeeded in abstracting away all the code for accessing the product's data by putting it inside a repository that lives inside the data layer. Okay, so let's continue on the next lesson.
Okay, that's the end of the module 3 for the app architecture. Oh, we have the wrapped up. Listen. That's it. It's just feedback. Okay. So that's it for today's lesson, and from next video we will go to the module 4, and we will start to use Riverpod. Thank you for watching, and bye bye.